Alright, hi everyone. So this is our last video in the Introduction to Differential Calculus section, and by now we should have learned all the rules necessary to do the AddMath paper at GCSE level, and we can start attempting some of the exam style questions. So here's one of the questions that I found on an exam paper. So y is equal to x minus 3 times ln 2x squared plus 1, and we have to find dy over dx. Find dy over dx. So first thing that we should do is identify what exactly are the rules we'll need. First thing we should note is that two values of x are being multiplied. The x minus 3 section, that's section 1. And then the ln 2x squared plus 1, that's also section 2. So to solve this, we just need to use the product rule because they're being multiplied by each other. So we can use the product rule. And if we recall, the product rule is u times v differentiated plus u differentiated times v. It's pretty simple. It's just you multiply the differentiated of one part times by the normal function of the other part. So in this case, let's just say our u is x minus 3, and our v is ln 2x squared plus 1. Now we can use our knowledge of differentiation to differentiate each of these separately to find our u prime and v prime. So u prime is very easy. X minus 3 differentiated is just 1, because the 3 becomes a 0 because it's a constant, and x differentiates to 1. And then for v prime, well, in the last video, we explored how ln gets differentiated. It's just the differentiated part that's inside the bracket divided by the normal function. So the part inside the bracket is differentiated to give 4x. And that's divided by the normal function, which is 2x squared plus 1. Now we have everything we need to know to do this. So we should do u times v prime first. So that's x minus 3 times 4x over 2x squared plus 1, plus, and then u prime, which is just 1, we don't really need to multiply by anything, plus, and then we just add ln 2x squared plus 1. Now, that's basically all we need to write. We could simplify this further by multiplying them together to give, that's a bad drawing, to give 4x squared minus 12x divided by 2x squared plus 1 plus ln 2x squared plus 1. So that's just how you differentiate it. You don't really need to go further than this. Sometimes they may ask you to use applications based on what you've just differentiated. And that's for another time. For now, we just focus on the differentiation part. So let's just move on to the next problem. So that's the answer for this one. Let's just attempt another one now. Alright, so for our next one, we have y equals 2x minus 1 divided by root of x squared plus 5, and we have to find dy over dx. So this is much harder than the previous one, just because A, we have a root sign in the denominator, B, we actually have a denominator. So the fact that we have a denominator and a fraction here suggests we need quotient rule. And let's just write down the rule here. So that's v times u prime minus v prime times u divided by v squared, if you recall. And we can identify that v is the denominator and u is the numerator. So we can say that v is equal to, let's just start with u first. So u is 2x minus 1, no problems there. And v is root of x squared plus 5. But to make it easier to differentiate, remember we should always write any surds or anything like that in the indices form. So this should be represented as x squared plus 5 to the power of half, because the power of half suggests it's under a square root. And now for u prime, 2x minus 1 differentiates to 2, and v prime, so we can use both the chain and power rules to do this. So this would become half x squared plus 5 to the power of negative half multiplied by 2x, which just becomes x times x squared plus 5 to the power of negative half. So I just did it rather quickly, but you can check it for yourself. It essentially just uses the same principles as the chain rule. Now we can just substitute into the equation. So that gives us x squared plus 5 as our v to the power of half, which is multiplied by u prime, which is just 2. And that's subtracted from v prime, which is x squared plus 5 to the power of negative half, which is multiplied by u, which is 2x minus 1. And this is all divided by the v squared. So that's x squared plus 5 because you just get rid of the square root. And we could simplify this further, but that would be pretty painstaking. So we're just going to leave it like this. This is good enough for now because usually with big ones like this, they don't actually expect you to simplify it. They might expect you to do something else with what you've been given, but they won't actually expect you to simplify it because this is quite a complicated thing to simplify. And you can do that on your own if you want, but it's not really necessary. This is how I'd leave the answer. So let's move on to the next problem. We'll do 1 or 2 more now. Okay, so the next problem is given that y equals x cubed divided by 2 minus x squared, find dy over dx. So immediately what strikes out is the division sign, the fraction sign, which means we're going to be using the quotient rule. And that's what we did last time, so we can just rewrite it now. That's let me write as v, sorry. V times u prime minus v prime times u over v squared. And we can immediately identify our u is x cubed and v is 2 minus x squared, and u prime is 3x squared, and v prime is, then the 2 just becomes 0, it becomes negative 2x. Now, what we can do is just substitute into the equation. So v times u prime, so that's 2 minus x squared times u prime, which is 3x squared. That's subtracted from v prime, which is negative 2x, times u, which is x cubed. And that's divided by 2 minus x squared squared. And I would say just leave the 2 minus x squared alone, but the rest we can simplify out. So that gives 6x squared minus 3x to the power of 4 plus, because 2 minuses become a plus sign, 2x to the power of 4 over 2 minus x squared squared. That just gives us, so we collect like terms, gives us 6x squared minus x to the power of 4 over 2 minus x squared squared. And we can just factor out the x squared in the numerator. X squared times 6 minus x squared over 2 minus x squared squared. And we can just leave it like this. This is perfectly fine. And that's this problem solved. Let's just do one more before we wrap up this video and effectively this section of the channel. So let's wrap up this video with this last problem. Find the derivative of y equals 3 sine 4x plus 5 cos 2x cubed. So this is actually not a very difficult problem, because if we recall, sine of x is equal to cos of x when differentiated. I'll draw an arrow to show process. Cos of x when differentiated gives negative sine of x. And remember, you multiply whatever's in the brackets over here. So we can say for the first term that sine becomes cos, and the 4 multiplies by the 3 to give 12 cos 4x. Remember, we retain the 4 over here. We don't actually just move it. And then this is added to, and I'll put in brackets here because there could be a sign change. And cos becomes negative sine, so it's negative. And then the 2, oh wait, but we don't do the 2 yet because, let me just make this a bit clearer. It's actually in brackets. So we differentiate whatever's in here. That gives us 6x squared. And we multiply 6x squared over here with the 5. So that's negative 30x squared. Then that's multiplied by cos 2x cubed, which gives us 12 cos 4x. Oh, before I forget, this is actually meant to be a sine. sine minus 30x squared sine 2x cubed. One way I like to think about it is when you have when you have a sine and a cos in the same thing, if you're able to collect the two, that means you've done something wrong because the cos and sine should switch places. So sometimes what I do is actually accidentally I'll change one of them to the opposite thing. So I'll change this to cos maybe, and then I'll leave this in cos, and I'll be able to like simplify it further by collecting the two, when really you shouldn't be allowed to do that because they'll switch over. So this is our final answer. 12 cos 4x minus 30x squared sine 2x cubed. And that's all we need to do for this problem. Like, it's not that hard. You just differentiate whatever's in the bracket, and then you multiply it by the coefficient of sine or cos, or whatever it is. And I think that I'm going to wrap it up for this video. And in the next few videos, I'll focus on the applications of differential calculus, because there are so many different things differentiation is used for. But thanks so much for watching, and see you in the next video.